and welcome to another NGen Math 7 lesson by eMathInstruction. My name is Kirk Weiler, and today we're going to be evaluating expressions with order of operations in Unit 2, Lesson 11. Now, up to this point, when we have done operations using negatives and positives, right, whether we're adding, subtracting, multiplying, and dividing, almost always it's basically been two numbers, and we've added them, or subtracted them, or multiplied them, or divided them, and we've gotten a result. But obviously, mathematical expressions, as we all know, can become more complicated. They can involve multiple operations. They can have both addition and multiplication in them, both division and subtraction, whatnot. And so we need to use order of operations, right? That standard kind of recipe of which comes first, which comes second, which comes third, etc., to figure out, well, the order that we perform the operations in. The big difference for today is for the first time, we're going to have some negative numbers included in our order of operations problems. So let's start off with a very simple example to help you think about the order of operations. Here we go, a review problem with a simple expression, exercise number 1. The expression 10 minus 7 times 2 is evaluated two ways shown below. Circle the correct one and explain why. Now this is very, very important, right? This expression, right, could easily be part of some greater problem. And we need to know the answer. And really it boils down to, should I do 10 minus 7, get a result, and multiply by 2, getting a final result? Or should I do 7 times 2, get a result, and then do 10 minus that result? So I'd like you to pause the video now and see which one of those two is actually giving us the correct answer. Now, I'm hoping that you all decided that it was choice 2, all right? And the reason that it is choice 2 is very simple, which is that multiplication comes before subtraction in our order of operations. I'll leave off that last part, but multiplication comes before subtraction. Now, don't get me wrong. Years and years ago when people were deciding, which operations come first, which come second, etc., they could have decided that subtraction came before multiplication, but that's just not the case, right? So when I see something like this, 10 minus 7 times 2, I literally have to think to myself, well, I'm going to do 7 times 2 and get 14, and then I'm going to do 10 minus 14 and get negative 4. I can't think of it as, well, I'm going to do 10 minus 7 and get 3, and then I'm going to do 3 times 2 and get 6. That would be incorrect. All right? Let's do another exercise to see if you can rank which things come first versus which things come last in order of operations. Here we go. Ordering the operations. Exercise number 2. Let's see what else you can remember about order of operations. Rank each of the following from first to fourth in terms of where they fall in the standard order. All right, great. So I really want you to, take your memory boxes out and think about this for a second. Read through each one of these 4. Choose the one that should come first and then the one that should come second, etc., etc. Rank them in terms of their order. Pause the video now and just take a few minutes to do this. All right, well, it's pretty simple. If everything is numerical, right, there's just a bunch of numbers, then the first thing that we should do is we should evaluate the expressions that are within the parentheses or in some way are kind of grouped together, right? So expressions within parentheses should come first. Then after we've done that, we should figure out exponents. That should come second. Once we've figured out the results of anything that have an exponent in it, then we're going to do multiplication and division, working from left to right. So if there's both multiplication and division, right, we should start from the left and we should move to the right through the calculation doing that. And then finally, the absolute last thing we should do is addition and subtraction, and again, moving from left to right through the mathematical expression. Right? A lot of times people use the acronym PEMDAS, sometimes using the phrase, please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, and subtraction. That's the order of operations, with multiplication and division tying, and addition and subtraction also tying, but then breaking the tie by working from left to right. Once we have order of operations, it means that we can evaluate more complicated expressions, many of which arise both in math and in science. So let's kind of get into that now. Here we go, exercise number 3. Use what you wrote in exercise 2 to evaluate each expression below. Show intermediate steps in your calculations. All right, well, let's do letter A together, and then we'll have you work on letter B on your own. So if I'm looking at this expression, before I really dive in, I'm thinking about it as 10 times the quantity -8 plus 2 times the quantity -6 to the second power. The first thing I really want to do is evaluate what's going on in these parentheses. So I'm going to do -8 plus 2, which is going to be -6. All right. The next thing my order of operations tells me to do is figure out this exponent. Now, of course, -6 squared is -6 times -6. And -6 times -6 is a positive 36, right? So then I'm going to have 10 times -6 plus 2 times positive 36. All right, awesome. Now what I'm going to do is I'm going to do this multiplication and this multiplication, and then as my last step, I'm going to add those two products together. But first, let's do the multiplication. We have positive 10 times -6. Anytime we have a positive times a negative, it's a negative. And of course, 2 times 36, well, that's pretty easy. That's positive 72. The last thing I'm going to do is combine that -60 with that positive 72, where I get some cancellation going on, and I get a final answer of positive 12. Step by step, right? I figure out what the result is in the parentheses. I then figure out what the result is of that exponentiation. I then find these two products. I then add the results of those as my last step to give me positive 12. What I'd like you to do now is pause the video and try to work through letter B. Go ahead and take a few minutes. All right, well in this case, we've got two expressions in parentheses that we should work through first. So let's do that right away. First thing I'm going to do is think about what 10 minus 13 is. I need to be very careful there. It'd be tempting to say positive 3, but it's in fact negative 3 because I have a smaller minus a larger. Then I've got negative 17 plus positive 7, and that's going to be negative 10. All right. Maybe the next thing I should do is figure out what negative 3 to the third power is. Now, if you can do that in your head, great. On the other hand, if you have to kind of come over to the side of the paper, right, somewhere over here and say, oh, well, that's negative 3 times negative 3 times negative 3, right? And then maybe I'd group these and I'd get positive 9 times negative 3, and that would be negative 27. That's fine. Do that on the side of your paper. Right, and that'll give me negative 27 minus 5 times negative 10. Okay, so now I've done my exponents. Now, technically what I should do next is the 5 times negative 10. I should do that next. And as we all know, a positive times a negative is going to be a negative. So that's going to give me as my next step, negative 27 minus negative 50. All right, I'm going to just finish this problem off. Negative 27 plus positive 50, right? Because subtracting a negative becomes adding a positive, and that ends up being a net positive 23, as we get some cancellation going on there. Order of operations, right? So let's move on and let's do some more problems using our order. Division within expressions. Now, in higher level math, the division symbol, that actual symbol that you've been kind of used to for most of your life for division, right, that symbol gets replaced by fractions. Now, I'd be remiss if I didn't point something out about this symbol. This symbol is actually the fraction symbol. Literally. That little dot with the bar and that little dot actually is a fraction. The idea are that the dots actually represent the two numbers, and that line is the fraction bar. That's where that symbol came from, right? That connection between division and fractions, right, is going to always be there, and almost never are we going to actually use this symbol, basically past this year. We're almost never going to use this symbol to actually show division. We'll almost always just simply have fraction bars. So let's take a look at exercise number 4. And just like we did before, let me move this to the top of the screen. All right, let's kind of do letter A together and have you do letter B on your own. But let's read through it first. Exercise number 4. Evaluate each of the following expressions that involve division in some way. Show your intermediate steps. All right, so let's take a look at this. This one looks a little bit funny, especially because that fraction bar is written in a little bit of a different way, but you will see them written that way, where it isn't really kind of written as 16 over 4, but kind of 16/4. But literally I have 16 divided by 4 minus 2 times the expression 6 squared divided by 3. Well, order of operations says I should deal with what's in parentheses first, and when I look inside of the parentheses, I see division, and I also see an exponent. So let's figure out the exponent first. That's fine, easy enough. I'm going to continue to leave that 16 divided by 4 minus 2. Now 6 squared is 6 times 6, so that's 36. There we go. Divided by 3. All right, I'm going to keep working on this for a second before we kind of pop out in a second, because I can now say 36 divided by 3 is just equal to 12. Move this out of the way. And let's take a look at this. Now, again, this can be visually very tricky, but up to this point saying, well, 6 squared is 36, and then 36 divided by 3 is 12, that's relatively easy. But now I look at this, and I've got both a division going on here, and I've got a multiplication going on here. And division and multiplication in order of operations are sort of expressions that should happen at the same time as we go from left to right. So literally, right, I'm going to do 16 divided by 4 and get 4, and then I'm going to do 2 times 12 and get 24. The last thing I should do is then 4 minus 24, right? And 4 minus 24, right? We could think of that as 4 plus negative 24. We can think about it in a variety of ways, but that is going to give me a final result of negative 20. Now what I'd like you to do is pause the video and take a shot at letter B. Go ahead and do so. All right, well, we got a lot going on here, although maybe not as much as in letter A. Right, I've got these two parentheses grouping this calculation, these two parentheses that are grouping this calculation, and a division that's going on in between them. Now, order of operations says I should really figure out what's inside of this parentheses, what's inside of this parentheses, and once I have, then I'll do that division. So let's take it a little bit at a time. When I look at this particular parentheses, right, the first thing I should do is 3 squared. And that's going to be 9, right? 3 times 3 is 9, and I have 9 minus 21. Now in this parentheses, I have 1 minus negative 2, which I can change into 1 plus 2. All right, that's easy enough. Let's keep going. Here, I'll have 9 minus 21, which is going to be negative 12. Be careful there, not positive 12. Divided by, and of course 1 plus 2, that's pretty easy, 3. All right, all of that is just simply working out what's in the two parentheses before I ever do the division. And now it's pretty easy. I have a negative 12 divided by a positive 3. Anytime we have a negative divided by a positive, our answer is going to be negative. And in this case, it's going to be negative 4. All right. It's amazingly important that you get past the use of that standard division symbol and also past the standard use of the x for multiplication, right? Because as you move on, you'll hardly ever see them at all. Now, let's keep going with this whole kind of fraction idea. Because, quite frankly, most of the time, right, we will have to work with sort of larger fractions like this, where kind of the numerator and denominator are grouped together kind of on their own. You know, perhaps we should put parentheses around them, but we don't need to. You know, the calculation in the numerator is kind of independent of the calculation in the denominator. So let's read through exercise 4 and then work through what these two expressions are equal to. Evaluate each of the following. Simplify the final division, fraction, into an integer, a reduced fraction, or a mixed number, whichever is appropriate. Now, these Look at these, like all four of them. We can barely see the ones down here. These look like beasts. So let's kind of work together on A and B, then I'll kind of turn you loose on C and D, and we'll go through them. Let's take a look at letter A. Here, I've got this 8 plus 2 in parentheses. So I think right away, I'm just going to figure out what that is, and of course 8 plus 2 is 10. Now, I think I'll just kind of leave it like this, but in the denominator, I think I'm going to work with this 2 to the third and this 2 to the fourth. 2 to the third is 2 times 2 times 2, which is 8. 2 to the fourth is 2 to the third times another 2, so that's going to be 16. Now, by the way, it's completely okay. You know, you might be like, oh, wait a second, why'd you do the exponents already? Well, that's okay. I can actually kind of work on the numerator and the denominator totally separate from each other. The only time I'm going to ever let the numerator and denominator interact with one another is once I've kind of simplified everything in both of them, then I might look at that fraction as division, and I might think about how I can simplify it. But let's kind of keep going on this one, because my next step is to figure out those products in the numerator. I've got 5 times 10, which is 50, and then I've got minus 2 times negative 3. 2 times negative 3 is negative 6. I think I'm going to do the subtraction in the denominator. There's no reason not to. 8 minus 16 will be negative 8. Be careful there. All right, I only have a little bit left. Right? And what I want to do now is I want to simplify the numerator, nothing more to do in the denominator, and then I'm going to do that division. Well, 50 minus negative 6 is the same as 50 plus positive 6. Of course, 50 plus positive 6 is 56, and 56 divided by negative 8, a positive divided by a negative is a negative, and specifically negative 7. All right. And again, it's completely okay. I could have completely worked through the numerator first, never even touched the denominator, then work on that one, and eventually do the division. But I can also work on them sort of at the same time. Let's do letter B together as well. Let's take a look at it first before we jump in. So we've got negative 3 raised to the third. All right, we're going to have to deal with that exponent, plus 11. Then in the denominator, I have negative 4 minus negative 6 squared. Right? So we're going to also have to deal with that exponent. Maybe we deal with those exponents first, right? Now we've already looked at negative 3 cubed today, and we saw that negative 3 cubed was negative 27. So I'm not going to rewrite that out, to kind of figure it out. But what I will do is I will start with negative 27 plus 11 in the numerator, not plus 1. All right? Let me just move this a little bit out of the way. Then in the denominator, I'll have negative 4 minus that negative 6 squared. Negative 6 squared is a positive 36. Now what's great about that calculation is in the numerator and the denominator, it's all just sort of addition and subtraction. So negative 27 plus positive 11 would be negative 16. And again, if you struggle thinking about this, I'd say consider thinking of it as negative 4 plus negative 36, because then it should be obvious that it's negative 40. Now finally, we get back into how do I simplify a fraction where the numerator and the denominator are negative? Well, a negative divided by a negative is a positive, so I'm going to have a positive result. And then 16/40ths, both 16 and 40 can be divided by 8. 16 divided by 8 is 2. 40 divided by 8 is 5, and so the answer to this expression is positive 2/5. All right, what I'd like you to do now, let me bring these to the top of the screen, is I'd like you to pause the video, and this may take you a few minutes because there's a lot of calculations you have to do in both of these, maybe especially this one, and come up with the final values of these complicated expressions. All right, so many places I want to start in letter C. Where? Well, I think I'll start by dealing with the exponents in the numerator and the denominator. Here we go. So, in the numerator, I have 3 squared, which is 9, minus 5 squared, which is 25. In the denominator, I have 4 squared, which is 16, plus, and I'm just going to actually do this product right away, plus 2 times negative 5, which is negative 10. All right? So I took care of my 2 exponents and I took care of my product. That leaves me in the numerator and the denominator just a bunch of addition and subtraction. 9 minus 25, or 9 plus negative 25, depending on how you want to think about it, is negative 16. In the denominator, 16 plus negative 10 is positive 6. Now I want to write that overall as either a negative fraction or a positive fraction. Because I have a negative divided by a positive, my answer is going to be negative. And now there's not much I can really simplify here. I can divide the numerator by 2, and that'll give me 8. And I can divide the denominator by 2, and that'll give me 3. So my final answer there, a very unsatisfying negative 8/3. Which we could also rewrite as a mixed number. If you wanted to, you could rewrite that as negative 2 2/3. Let's take a look at letter D, which seems even more complex. Again, I think I'm going to jump in, deal with any exponents I see in both the numerator and the denominator, and we'll take it from there. So, let me just move this a little bit further. All right, here we go. In the numerator, we've got 2 cubed, which is 8, and then not much more than I'm going to do with that yet. We'll come back to it. That's beautifully done. In the denominator, I have 10 squared, which is 100, minus, let's take a look at this parentheses, 9 squared, which is 81, plus 11. All right. Now, I think I'll deal with what's going on in both of these parentheses. Okay, so I'll still leave that sort of multiplication business by itself, 5 times 8. Then I'm going to have minus 4 times negative 12, right? Negative 4 minus 8 is negative 12. Down here it's a little bit easier. We just have 100 minus 92. All right. I think we're going to have a little more room here. So try to extend the page a bit and bring this back up. Let's take a look at this, just pausing for a minute. Right now, I've got a little multiplication left in the numerator before I kind of combine them with that subtraction. So let's do that. I've got 5 times 8. Which is going to give me 40. And I have minus 4 times negative 12, which is negative 48. Come on. There we go. All divided by 100 minus 92, that's pretty easy, which is just 8. Finally, in that numerator, I have 40 plus 48, right? Because I'm subtracting a negative. 40 plus 48 divided by 8. So that gives me 88. Beautiful, divided by 8, and that is a nice answer of 11. All right, so sometimes a very, very ugly looking calculation like this can turn out to be quite a nice number at the end. All right, let's wrap this up. So in today's lesson, we literally didn't see anything new. We already knew about order of operations. We knew that you should do things in parentheses first, then exponents, then multiplication and division, then addition and subtraction. We knew that. All right. The big difference today is we started to involve negative numbers and all the rules that go along with negative numbers. Everything we've learned in this unit, and we're on lesson 11. This has been a long unit. All the things we've learned in terms of adding sign numbers, subtracting them, multiplying, dividing them, exponents, and even simplifying fractions that have negatives and positives in them. All of that came in today. In the next lesson, we'll look a little bit about how you can deal with negative numbers on the calculator, but it's exceptionally important to really kind of master the basic mechanics of negative and positive numbers without using a calculator first. For now, I just want to thank you for joining me for another NGen Math 7 lesson by eMathInstruction. Until next time, keep thinking and keep solving problems.